Assalamu alaikum wa rahmatullah. Today, inshallah, we're going to solve Cambridge exam, October-November 2022, paper 42. Let's start it. Question 1. Diamond and graphite are different solid forms of carbon. The carbon atom in diamond and graphite arranged in different ways. State the number of covalent bonds each carbon atom has in diamond. In diamond, each carbon atom is bonded to 4 other carbon atoms, so the number of covalent bonds is 4. State the term used to describe the structure of diamond. Diamond is a giant covalent structure. Name an oxide that has a similar structure to diamond. In our syllabus, we have silicon dioxide with the same structure to diamond, but each silicon atom is bonded to 4 oxygen atoms, and each oxygen atom is bonded to 2 silicon atoms, and the covalent bond extended through the whole tetrahedral structure. Describe the arrangement of atoms in graphite. In graphite, carbon atoms arranged in hexagons, and these hexagons linked into layers. So we can write carbon atoms arranged in layers of hexagons. Explain how graphite can conduct electricity. Carbon atom in these hexagons, each carbon atom is bonded to 3 other carbon, leaving 1 electron not involved in the bonding. So these free electrons that can move between the layers carry the current. We have a molecule of Buckminster fullerene. It's a simple molecular form of carbon. The relative molecular mass is 720. Determine the number of carbon atoms in 1 molecule of Buckminster fullerene. First, we will have the relative atomic mass of carbon, which is 12. So we will divide the total molecular mass of the molecule by the mass of 1 atom to get the number of carbon atom in the molecule, which is 60. All forms of carbon burn to produce carbon dioxide. Name the substance used to test for carbon dioxide. Lime water is used to test carbon dioxide. When carbon dioxide passes through the lime water turns turbid or milky due to the formation of calcium carbonate. Question 2. Sodium is a reactive metal. Suggest why sodium is stored under oil. Because sodium is very reactive, it will react with oxygen and water vapor in the air. So we store it under oil to prevent its contact with oxygen in the air. Sodium burns in air to form sodium oxide. State the term given to a reaction in which substance burns. Burning is called combustion reaction. State the color of the flame seen when sodium burns. The flame color for sodium is yellow. Write a chemical equation for the reaction which takes place when sodium burns in air to form sodium oxide. So we will write sodium plus oxygen, it will give sodium oxide, and the formula of sodium oxide is already given here. But remember that this equation is for 2 marks, so you have to balance the equation. Here we have 2 oxygen, so we will multiply this by 2. Now we have 4 sodium, so we will multiply here by 4. Complete the dot and cross diagram to show the electron arrangement and charges of ions in sodium oxide. Sodium oxide, it has 2 sodium ions and 1 oxygen ion. So each sodium atom will lose 1 electron to form sodium ion with 1 positive charge. And now the total number of electrons in each sodium ion will be 10, arranged 2 in the first shell and 8 in the second shell. And these 2 electrons lost from 2 sodium atoms will be gained by 1 oxygen atom to form oxygen ion with a charge of -2. Remember that these 2 electrons will have the cross symbol because they are coming from the sodium atoms. Sodium reacts vigorously with water to form aqueous sodium hydroxide, which is a strong base. Explain in terms of proton transfer what is meant by a base. He wanted to explain in terms of proton transfer, so base is a proton acceptor. State the pH that indicates the presence of strong alkali. Strong alkali, we can write pH 14. State the color of methyl orange in aqueous sodium hydroxide. A methyl orange is yellow in alkaline media, orange in neutral media, and red in acid media. So here we have sodium hydroxide, which is strong alkali, so the color will be yellow. The equation for the reaction is shown, reaction between sodium and water, and the products are sodium hydroxide and hydrogen gas. Calculate the concentration of sodium hydroxide in gram per decimeter when 0.345 grams of sodium added to 50 centimeter cube distilled water, and assume there is no change in volume. So here we have the mass of sodium and the total volume of water. First, we will calculate number of moles of sodium. The mass divide the atomic mass of sodium will give us the number of moles. So this is the mass given here, 0.345 divided by 23, which is atomic mass of sodium, and the number of moles of sodium will be 0.015 moles. Then, to calculate the number of moles of sodium hydroxide formed, we will refer back to the equation here. The ratio of number of moles of sodium to number of moles of sodium hydroxide is 1:1, and that means the number of moles of sodium is equal to the number of moles of sodium hydroxide. So we can directly write that the number of moles of sodium hydroxide is the same, 0.015 moles. Then we want to calculate the concentration of sodium hydroxide in mole per decimeter cube. So the number of moles equal to the concentration multiplied by volume, and remember that we have to write the volume in decimeter cube. We know the number of moles, and the volume is 50 divided 1000 to be in decimeter, so it is easy to get the concentration, which is 0.3 mole per decimeter cube. Then we want to calculate the concentration in gram per decimeter. That means we have to know how many grams in 0.3 moles. First, we will calculate the relative formula mass of sodium hydroxide, which is 23 for sodium, 16 for oxygen, and 1 for hydrogen. The total mass will be 40. That means that 1 mole of sodium 1 mole of sodium hydroxide has 40 grams. How many grams it will be in 0.3 moles? So by simple cross multiplication, we can find that 0.3 moles contain 12 grams. So the concentration will be 12 grams per decimeter cube. When sodium hydroxide aqueous is added to aqueous iron chloride, iron 3 chloride, a solid product is formed. Name the type of reaction where a solid is formed from two solutions. Adding two solutions together to get a solid precipitate is called a precipitation reaction. State the color of this solid product. Here, I already wrote the equation. Sodium hydroxide with iron 3 chloride. The product formed is iron 3 hydroxide, which is a red-brown precipitate. Name this solid product. The name of the product is iron 3 hydroxide. Write the name, not the formula. So we will write iron 3 hydroxide. Write the ionic equation for the reaction, including state symbols. So here, to write the ionic equation, we will remove the spectator ions, the ions that didn't take any part in the reaction. It was here in aqueous state and get out in the product in the same aqueous state. So we have sodium ions is a spectator ion. It is the same state. It didn't take part in the reaction. And also chloride ions. It was in aqueous state here in the reactant and exit here the same way in aqueous state. So what will be left here? Hydroxide ions, iron 3 ions, and the product which is iron 3 hydroxide. So the ionic equation will be iron plus 3 aqueous plus hydroxide ions minus 1 aqueous to give iron 3 hydroxide solid. This ionic equation is for 3 marks, 1 mark for the correct charges on the ions, the other mark for the correct formula of the product, and the third mark is for the state symbols. Sulfuric acid is manufactured by industrial process. Sulfur is obtained from sulfur-containing metal ores. So the sulfur is in the metal ore is converted first to sulfur dioxide, and then it is oxidized to sulfur trioxide as shown here in the equation. Name the metal ore which contain sulfur. The metal ore that contains sulfur is zinc blende. Describe the process which converts the metal ore to sulfur dioxide. Heating this metal ore in oxygen in air, it will burn the sulfur into sulfur dioxide. So the process is heating the ore in air. Name the industrial process used to manufacture sulfuric acid. Sulfuric acid is manufactured by contact process. The reaction that produces sulfur trioxide is an equilibrium. The forward reaction is exothermic. So this reaction on the right side for formation of sulfur trioxide is exothermic. State the temperature and pressure used to make sulfur trioxide. Temperature and pressure are the condition needed for the contact process. So we all know that the temperature is 450 degrees Celsius and the pressure is 1 to 2 atmospheric pressure. The catalyst used is vanadium pentoxide. Describe the two features of an equilibrium. In equilibrium, the rate of the forward reaction equal to the rate of the backward reaction, and the concentration of the reactant and the products are constant. State the effect, if any, on the position of equilibrium when the following changes are made, and explain your answer. If the temperature increased, so the equilibrium will be shifted to the left-hand side. It is already mentioned here that the forward reaction is exothermic, so increasing the temperature in an exothermic reaction will favor the backward side or the endothermic side. Say the effect on the position of equilibrium if the pressure increased. The position of the equilibrium will move to the right-hand side. If we increase the pressure, the position of the equilibrium will be shifted to the right-hand side, to the forward reaction, because this side has less number of moles. As we can see here, we have 2 moles, and on the left side, we have 3 moles. So increasing the pressure will favor the side of less number of moles, which is the right side. Explain in terms of particles what happened to the rate of the reaction when the temperature increased. So we want the effect of increasing temperature on the rate of reaction. How can it affect the particles and the rate of reaction? Increasing temperature will increase the kinetic energy of the particles. So the particles will move faster and it will collide more frequent. More frequent collision will happen per second or per unit time, and more particles will have energy equal to or more than the activation energy needed for the reaction to happen, and that will increase the rate of reaction. Name a compound formed when sulfuric acid react with ammonia. When sulfuric acid react with ammonia, the product is ammonium sulfate. Ammonia plus sulfuric acid, the product formed is ammonium sulfate. And this is the formula of ammonium sulfate. Of course, you here required only to write the name of the product, which is ammonium sulfate. A student prepare magnesium sulfate crystal by adding excess magnesium to dilute sulfuric acid. Write a chemical equation for this reaction. Magnesium metal plus sulfuric acid will give magnesium sulfate and hydrogen gas. Describe two observations which show that the reaction has finished. We can know that the reaction has finished when the fizzing of the hydrogen gas stops, so when no more fizzing. Number two, when the solid, which is magnesium, when the solid stops dissolving. The excess magnesium is removed by filtration. State the general name given to the solid separated by solution by filtration. By filtration, we separate a solid which remains in the filter paper, and this solid is called residue. The aqueous magnesium sulfate is heated until crystals begin to appear. Suggest the name for a solution in which no more solute can dissolve. The solution is called saturated solution, in which no more solute can dissolve at a given temperature. Suggest why more crystal of magnesium sulfate will appear on cooling. By cooling, the solubility will decrease, so the magnesium sulfate crystal will start to crystallize out from the solution. Solubility of magnesium sulfate decreased by cooling. Magnesium sulfate crystal have the formula of MgSO4 and X molecules of water, where X is a whole number of the molecules of water. A student heat the crystal to remove the molecules of water. As we can see, here is the hydrated magnesium sulfate crystal with water, and here is the anhydrous magnesium sulfate crystal without water. Name the term given to the crystal contain molecules of water, which is this one. It is hydrated crystal. The student heat a sample of magnesium hydrated crystal to find it had lost 0.14 moles of water, and the final mass remaining, which is anhydrous magnesium sulfate, 2.4 grams. First, we want to determine the value of X by the following steps. First, we will calculate the MR for magnesium sulfate. So the formula mass of magnesium sulfate is 120 grams. Then the number of moles of magnesium sulfate will be the mass of the anhydrous magnesium sulfate, which is 2.4 grams, dividing by the molar mass, which is 120. So number of moles of the anhydrous magnesium sulfate is 0.02. Here, it's already mentioned that we have 0.14 moles of water lost by heating. So the number of moles of water is 0.14. This number of moles present with 0.02 moles of magnesium sulfate. For each 0.2 magnesium sulfate moles, we have 0.14 moles of water. So we want to determine the value of X in this formula. Here in the formula, for each 1 mole of magnesium sulfate, we have X moles of water. So by simple cross multiplication, we can find the value of X, which will be 7. If the student uses dilute nitric acid instead of dilute sulfuric acid, the salt formed is magnesium nitrate. Write a chemical equation for the reaction when solid magnesium nitrate is heated. Heating magnesium nitrate, the nitrate will decompose into magnesium oxide, nitrogen dioxide, and oxygen. Again, this equation is for 2 marks, so 1 mark will be for balancing the equation. Question 5. Ethane is an alkane which undergoes a photochemical reaction with chlorine as shown. Write the general formula of alkane. It is CnH2n plus 2. State why the reaction is described as a photochemical reaction. This reaction happens only in the ultraviolet light, so it is called photochemical because it needs ultraviolet light. In this reaction, an atom of hydrogen is replaced with a chlorine atom. State the name of this type of organic reaction. This reaction is a substitution reaction in which one of the hydrogen atom is substituted by chlorine atom. In this reaction, One of the product is chloroethane. Name the other product. Here we have chloroethane, so the other product is hydrogen chloride gas. The energy profile diagram of this reaction is shown. Name the energy labeled A. A is the activation energy needed for the reaction to happen, so A is the activation energy. Name the part labeled B. B is the energy change of the reaction, the delta H for the reaction. State how the energy profile diagram shows that this reaction is exothermic reaction. From the diagram, we can see that the product at lower energy level than the reactant. That means the energy released from the reaction when the products are formed. So this is an exothermic reaction. The equation for the reaction can be represented as shown. Here we have ethane, chlorine. The products are chloroethane and hydrogen chloride. The bond energies are shown here in the table. Use the bond energy in the table to calculate the energy change of the reaction. First, we will calculate the energy needed to break the bonds. We have 6 carbon-hydrogen bonds and 1 carbon-carbon bond, 1 chlorine-chlorine bond. The total energy needed to break the reactant bonds is 3050. Then we will calculate the energy released by making new bonds. Here we have 5 carbon-hydrogen bonds and 1 carbon-carbon, 1 carbon-chlorine bond, and 1 hydrogen-chlorine bond. So the total energy released by making new bonds will be 3170. Then we will determine the energy change in this reaction. The delta H will be the energy needed to break the bonds minus the energy released by forming new bonds. It will be minus 120 kilojoule per mole. Question 6. Carboxylic acid Y has the structure shown. State the general formula of carboxylic acid. The general formula is CnH2n plus 1 COOH. Name the carboxylic acid Y. Carboxylic acid Y is carboxylic acid with only 1 carbon atom, so it is methanoic acid. Write the molecular formula of the carboxylic acid Y. The molecular formula is the number of each type of atom present in the molecule. So we have 1 carbon, we will write C, 2 hydrogens, H2, and 2 oxygen, O2. So the molecular formula will be CH2O2. Complete the dot and cross diagram to show the arrangement of electrons in molecule of the carboxylic acid Y. Here we have the carbon atom, 1 single bond with hydrogen, 1 single bond with oxygen, 1 double bond with the other oxygen atom, and we have also another single bond between oxygen and hydrogen. Each single bond formed by sharing a pair of electrons, 1 from each atom. So here we will have the first covalent bond between hydrogen and oxygen, 1 electron from each atom. Another single bond between oxygen and carbon, 1 electron from each atom. Then we will complete the number of outer shell electron for oxygen to be 8 electrons. So we will draw the lone pair of electrons. Oxygen has 2 lone pairs. The total number of electrons around oxygen atom will be 8. Then here we have another single bond between carbon and hydrogen, 1 electron from each atom, and a double bond between the oxygen and carbon. Here 2 electron from oxygen and 2 electron from carbon, and again don't forget the lone pair of electron for the oxygen atom. Carboxylic acid Y will react with propane 1-ol to form ester Z and one other product. Name and draw the structure of ester Z. Show all the atoms and all the bonds. The carboxylic acid Y was methanoic acid. So I'll draw here methanoic acid, which has one carbon atom. We know that the ester named after the parent acid, so it will be propyl methanoate. And the structure of propyl methanoate, first we will draw the part that comes from the acid, then we will draw the alcohol part, which has 3 carbons because it's a propanol, C3. So this is the alcohol part, 1, 2, 3, the part that comes from alcohol, and 1 carbon, which is a part comes from the methanoic acid, and here is the ester linkage. Name the other product formed when carboxylic acid Y react with propane 1-ol. When carboxylic acid react with alcohol to form ester, 1 molecule of water is removed, so the other product formed is water. Name an ester which is the structural isomer of ester Z. Isomers are compounds having the same molecular formula but different structural formula, so we can just reverse the acid and the alcohol part to get the isomer, and instead of propyl methanoate we can write methyl propanoate, so it will be the isomer of ester Z. The carboxylic acid, which is a structural isomer of ester Z, which is an acid, have the same molecular formula of ester Z. So this acid, which is an isomer for ester Z, should have 4 carbon atoms, 2 oxygen atoms, and same 8 hydrogen atom, and this acid will be butanoic acid, as shown here in the structure: 1, 2, 3, 4 carbon atoms, 2 oxygen atoms, and 8 hydrogen atoms. This is the structure of butanoic acid. Now we reached with the end of our exam. Comment down below if you have any question. Like the video and subscribe to the channel to receive all the updates. Thank you for watching. Wish you all best of luck.